All right, folks. On this slide, we'll finish the part 1 of naming ionic compound. Okay. Well, I want to remind you one thing, and that is these main group metals. Okay. Well, as you notice that for group 1, they always lose one electron to become cations with one positive charge. Okay. A lithium 1 plus, a sodium plus, a potassium plus, a rubidium plus, and cesium plus. You don't have to show 1. You just need to show plus. That tells people that this is actually 1 plus. Okay, this is a group 1 metal. Group 1 metals. Yeah. How about group 2? Well, they tend to lose 2 electrons to get cations with 2 positive charges. Okay. Group 3 metal, aluminum, tends to lose 3 electrons to get 3 positive charges. Okay. But in chemistry, we have some metals. Okay, so for in the previous slide, these metal main group metal elements, they have only one charge. Okay, but in chemistry, for some of the metals, they could have more than one charge. Let's see this example. For instance, chromium, it could lose 2 electrons to become chromium 2 plus, or 3 electrons to become chromium 3 plus. Copper, it could lose 1 electron to become copper 1 plus, or 2 electrons to become copper 2 plus. So in this case, how do we deal with the naming of the ionic compound that have these type of metal ions? Okay, here this is the rule that we need to follow. Okay, let's take a look at some examples. Let's see FeCl2. This is the formula of this ionic compound. How do I name it? First one is you need to identify the charge of iron, Fe. Okay. Well, if you happen to remember what we learned on the previous slide, Cl, chloride, and you have 2 chloride. That means in this formula, Cl minus, Cl minus. And remember, this formula tells you that the whole compound is neutral. So when you have only one iron, it has to be 2 positive charge to balance the whole 2 Cl minus. Okay, so I know now the iron is 2 plus. Okay, now let's name this compound. Well, name of the cation metal, it's gonna be iron. Okay, iron here. So IRON. And the charge of the cation in the Roman numerals, since it's 2 plus, so parenthesis and 2 inside. And then the base name of the anion plus IDE. It's just going to be the chloride. Okay. One more example. How about Cu2S? Okay. We know from the previous slide, S, sulfide, and sulfide is S2 minus. Okay. Now, you can see that for this whole formula, it has 2 Cu, 2 copper ions. Okay, so let's write it down here. Okay, apparently it has to be positively charged. So let me put the question mark plus, okay, for each one of them. Okay, why do I write the whole thing like this? Okay, if you can do your calculation in your mind, you will realize the question mark should be 1. Because if you have 2 Cl, 2 copper 1 plus, then the charge is balanced. But even if you get confused, according to the property, the second property of ionic compound, question mark plus question mark, okay. Okay, if you add them together, it should equals to 2, right? Because the charge has to be balanced. And if you calculate the value of each question mark, So that would be question mark 2 divided by 2, that equals to 1. Okay, so that's how I know that copper is 1 plus. Okay, now when you reach here, you can give it a name. That will be copper. Since it's 1 plus, parenthesis, numeral, the Roman numeral would be 1, and sulfide. Okay, so this is how we name those ionic compounds with those metals that could have more than 1 charges. Okay. Okay. Next slide, the part 3 of naming ionic compound. Well, this slide, we'll spend enough time on this slide. Okay. This slide shows you the polyatomic ion. It's very important, and also it could be confusing or challenging. Okay, let's take a look at those polyatomic ions. So far, before we talk about this slide, if you go back, you can see these ions have only one element or one atom. Okay, but for polyatomic ions, each one of them has more than one element or more than one atom. That's why we call it polyatomic, right? Okay, so most of them are anions, as you notice. Okay, and in this table, there is only one polyatomic cation, that is NH4 plus. Okay, otherwise, most of them are negatively charged. Okay, for those polyatomic ions highlighted by the red squares, they are required. I want you to be very familiar with those names and those formulas. Okay, so when I give you the name of ionic compound, I need you to write the formula, or when I give you a formula and ask you to name it, okay, if you can remember the names of those ions, that will be helpful. Let's take a look at some example. Okay, sodium Na2CO3. How do we name this ionic compound? Well, it's sort of like the the part 1 name of the compound. Let me write it here. The name of the cation, okay, most likely, okay, like we said, that most of the cations are metals, and only one cation is formed by non-metal elements. Okay, so plus the base name plus ATE or ITE or IDE. Okay, these are the common tell for the name of those polyatomic ion. Let's see some examples here. Okay, so ATE acetate, IDE hydroxide, and ITE nitride. Okay, so let's name this Na2CO3. Well, apparently Na would be sodium, and CO3, as you take a look, that it's going to be carbonate. So carbonate. Okay. All right, let's see this one. NH4Cl. Well, NH4, ammonium. Cl from the part 1, it's chloride. Okay, so the name of this compound would be ammonium chloride. All right. Some more example. How about FeCO3? Okay. Well, we know Fe is the metal, one of the metal ions that could have more than one charge, right? So the first thing is to figure out the charge of the iron, Fe. We know that for CO3, it's 2 minus, as shown from the table here. In order to balance the charge, it looks like iron has to be iron 2 plus. Okay, so in this case, the name of this compound would be iron 2 carbonate. Okay, the iron 2 carbonate. Okay, how about this one? CuNO2 2. Okay, now it's getting interesting because you can see that it has 2 here and one more 2. What does that mean? Okay, for each 2. When you have the 2 right here, that represent that you have 2 oxygen atoms in this NO2 minus anion, because for each NO2 minus, that 2 will follow oxygen. That tells you for this polyatomic ion, it has 2 oxygen in this ion. But how about this 2? This 2 means that you have 2 NO2 minus in this ionic compound. Okay, I write 2 NO2 minus in this case. Okay, how do we name the compound? Well, if you remember, copper is one of the metal ions that could have more than one charge. Therefore, we need to figure out the charge of the Cu. As I mentioned here, you have 2 NO2 minus in this ionic compound. Therefore, the total negative charge would be 2 minus. And in order to balance the charge, copper looks like it has to be 2 plus to balance the charge. Okay, all right, so when we name this compound, that would be copper 2 nitride. Right here, okay, let me point out nitride. Okay, so these are the naming of ionic compounds with polyatomic ions. Okay, all right. Part 4 for naming of ionic compounds. Well, some of the ionic compounds, they have hydrates. Oops. Okay, and the hydrates could be 1, could be 2, could be 4, 5, 7. Okay, so how do we name the hydrates? We need to name those hydrates. We need to include the hydrates in the names of those ionic compounds, because those hydrates, water molecules, they are part of the formula. Okay, for instance, this picture shows you the cobalt chloride with 6 water in it. Okay, it shows you very beautiful deep red color. For cobalt chloride only, without any water molecule, color is different. It's purplish. Okay, so looks like with hydrate, without hydrate, they show some different properties. So we do need to give them different names. Okay, let's talk about this one, cobalt chloride. Cobalt chloride looks like you have 2 chloride, 2 negative charges for cobalt, for anions. In order to balance the charge, looks like cobalt has to be 2 plus. All right. Okay. So when you give it a name, that's going to be cobalt 2 chloride. Okay. Now, how about the cobalt chloride with 6 hydrates? Well, if you can see that we need to use the prefix for the hydrates. If you have 6, then you use hexa. Okay. That will be cobalt. The charge of the cobalt is still 2. Okay. Cobalt chloride and now hexa hydrate. Okay. So 6 water molecules. Okay. Let's take a look at more examples. How about this one? CuS4 with 5 water molecules. Remember, I have a dot here. Okay. The dot means for one CuSO4, there would be 5 water molecules around this part. Okay. These water molecules are not interacting with the copper sulfide directly. Okay. There might be some weak interactions, but not through chemical bonds. Okay. So we use this dot to represent that water molecules are around, but not closely interacting with the copper sulfate. Okay. But those hydrates are part of the compound. That's what this dot means. Okay. We'll have a lab about the hydrates, and you'll get more experience about this. Copper sulfate. Now, the anionic part is SO4. If you are familiar with the polyatomic ion, you realize SO4, it is an anion and it has 2 negative charges. Okay. Now, in order to balance the charge, it looks like copper has to be copper 2 plus. Therefore, the name of this compound should be written as copper 2 sulfate. Okay, when you have 5 hydrates, 5, the prefix for 5 is penta. Okay, I'll write it down here, penta hydrate. Okay, pentahydrate. Let's try one more example. CaNO3 2 half water. Okay. Now, calcium from group 2. Well, if you happen to remember what we talked about in part 1, ionic compound naming, you realize that Ca has only one possible charge. That's going to be 2 plus. Lose 2 electrons to become 2 plus. Okay. So you don't need to use this kind of numeral, the Roman numeral for calcium in this case. Okay, main group elements. So it would be calcium and nitrate. Okay. Now you have half water molecules for each calcium nitrate. Okay. For half, the prefix is hemi. So you wrote that as hemi hydrate. Okay. I don't need you to memorize all of these prefixes, okay? You just need to remember those highlighted by red square, and that's good enough. Okay, so these the ionic compound with hydrates. Now it's time for us to take a look at the covalent compound. Okay, we know that when we discussed ionic compound, we said that for ionic compounds, you have to have cationic parts and anionic parts. In other words, you have to have positive charged parts and negative charged parts. But for covalent compound, it's going to be different. Okay, for covalent compounds, most likely they are going to be formed by nonmetal elements. And when you deal with nonmetal elements, okay, they are going to share, most likely they are going to share electrons. Okay, so there won't be any cationic parts or anionic parts since they are sharing electrons, right? So the name rule would be different in this case. Okay, let's see. This is the name, the rule, the naming rule for binary covalent compound. In other words, you would have just two. You would have just two elements. Okay, two non-metal elements in this kind of compound, binary. Okay, and here, first part prefix, and these are the prefix. We've already seen them on the previous slide. Name of the first element, and then prefix for the second element plus IDE. Okay, let's see some examples. Okay, let's see SF3. Okay, sorry, SF6. Okay, SF6. All right. For SF6, according to the naming rule, since it has only one sulfur, it looks like we should use the mono for as a prefix for this first element. But you know, in chemistry, if you have only one atom for the first element, you can ignore the mono. So instead of, let me write this down. Okay, so it looks like according to the rule, okay, if we want to be perfect, it would be mono sulfur. And now the six F, so it would be hexa fluoride. Okay, but like I said, that if you have only one atom for the first elements, you don't have to write the mono. So instead of writing the name of this compound as monosulfur hexafluoride, you should write that as sulfur hexafluoride. Okay, I'll put a cross. Okay, do not write the mono for the first element if it has only one atom in the formula. Okay, now let's do more practice. How about H2S? Well, this time you have two hydrogen atoms, first element. Okay, so you should write that is di hydrogen. And then, because this is the second element, sulfur, it has only one. But if you are talking about the second element, even if you have only one atom for the second element, you still need to write the prefix, which is mono sulfide. Okay, remember, it's the base name plus IDE. Okay, all right, let's do more practice. S2, Cl2. Well, in this case, it would be disulfur chloride. Okay, and one more example, N4O. Well, you have 4 nitrogens. Okay, so that's going to be tetra nitrogen, mono oxide. Remember here, if the name of the second elements start from the oxygen, start from the O, then you don't need to write the MONOOXIDE. You can just have one O, okay, because the prefix for one end up with O. So in order to avoid that kind of redundant situation, we should just write one O, okay, monoxide. Let's practice some more example. For this one here would be boron trifluoride, right? You have only one element, okay? Now the second example here, sulfur dichloride, okay, dichloride. The C and the D, these are the names of the binary covalent compound, okay? They ask you to come up with the formula. Well, xenon, Xe, dioxide, oxide, and you have 2 oxide. That's how we come up with the 2 right here. It comes from the Di, okay? Sulfur tribromide, sulfur, S, bromide, and you have 3 bromide from tri right here. So this is the formula, okay? This is the formula of sulfur tribromide. One last question here for the naming of binary covalent compound is, why do we have to have those kind of prefix? Well, the thing is, let me give you some example. Between nitrogen and oxygen, if you combine these two, it will form multiple binary compounds with different number of the nitrogen and oxygen atoms, like NO, N2O, NO2, and we saw that N4O, N2O3, and N2O4, and N2O5, okay, and so on. And if you don't have the prefix for these elements, and if you just call them nitrogen oxide, it's going to be very confusing here, right? Because nitrogen oxide could have more than one formula. So in order to distinguish those binary covalent compound with nitrogen and oxygen, so we do have to use those prefix to distinguish them, okay? All right, need more practice, okay? Please go ahead. And if you have any questions, let me know.